Okay, so here we have three types of equations that we can start off as a base, and from these we'll be substituting numbers, and we'll be working out potential quadratic equations that we can use for modeling this bridge, the Sydney Harbour Bridge. Okay, so the first thing that we will do, and I can do the working out on the left hand side here. So we need to know we have these 3 points. Okay, so these 3 points is what we have: minus 7, 0, being this one here. You can see it on the left hand side of the bridge. We have 7, 0 here on the right hand side of the bridge, and we have 0, 2, which is this over here. Okay, so we will be using these 3 points in our equations, the standard form, vertex form, and intercept form, to solve them. Okay, so to make space, what I'm going to do is I'm going to take out these points here that are on the left hand side, and I'm going to start off with the standard form. Okay, so this form, it is actually maybe even perhaps the most difficult of the 3, but just because I wrote it first here on the list, we may as well get it out of the way. Okay, so with the standard form, what we're going to need to use is simultaneous equations, which means we're going to be solving 2 or more equations at one time. So taking the standard form, so if I rewrite it, make this slightly smaller, so we have y is equal to ax squared plus bx plus c. Now we're going to directly substitute each of the points that we know into this equation. So the first point here being negative 7, 0. So this means, so sub negative 7, 0. From this, what we get is 0 for the y equals to a minus 7 squared plus b minus 7 plus c. Okay, and to simplify this a bit further, we will have 0 is equal to negative 7 times negative 7, negative times negative positive, so we have 49a minus 7b plus c. Okay, and we will call this our equation 1. And then the next point that we can sub is 7, 0. So that is this point here on the right hand side. So there's sub 7, 0. And again, putting it back into this original equation over here. So we have 0 is equal to a, this time 7 instead of minus 7, 7 squared plus b times 7 plus c. Simplifying this again, we have 0, again 7 squared just like minus 7 squared is 49a plus 7b. So instead of minus 7b here we have plus 7b plus c. We will call this equation number 2. All right, and we have one last point because we're going to have here we have 3 unknowns, so a, b, and c, so we're going to need 3 equations. Okay, if we had 2 unknowns, we will only need 2 equations. So for the third equation, to obtain that third equation, we're going to have to substitute this last point up here, the 2. So this is 0 on the x, so over here 0 on the x, 2 on the y, so we have 0, 2. Okay, from here then, again substituting in here, this one will be the easiest. So the y is 2 instead of 0 this time. And ax squared plus bx plus c, so the x is 0, so it's a times 0 squared plus b times 0 plus c. Alright, and then we have 2 is equal to c. Alright, which means just c is equal to 2. Now that we know c is equal to 2, we want to substitute c is equal to 2 into, so we're going to c is equal to, that's 3, so we're going to say sub 3 into 1. So doing that, we get 0 is equal to 49 a minus 7b plus 2. Okay, and then we can also substitute 3 into 2. Sub 3 into 2. And what we get is 0 is equal to 49a plus 7b plus 2. And you know how before I said simultaneous equations, so the way they work is if we have 3 unknowns, so I'll do a bit of highlighting here just to make it clearer. 3 unknowns here, a, b, c, so we have 3 unknowns, right? And here's the c, so if we have 3 unknowns, we need 3 equations, here being equation number 1, we got it from minus 7, 0, equation number 2 from 7, 0, and equation number 3, we got it from the point 0, 2. All right, so now, so this is, in this case, we have 3 equations, so 3 equations and 3 unknowns, a, b, and c. Here, in this case now, we're still doing simultaneous equations, except this time we have 2 equations and how many unknowns? Here we are, a and b, 2 unknowns. And therefore we can go further to find what the unknown is. Okay, so going further, what can we do? So let's say this here now is the top equation is, so because originally it used to be equation 1, which is this one here, equation 1. So now because it's changed slightly from 49a minus 7b plus c to 49a minus 7b plus 2, we're going to call this equation 1 with a little dash or prime here, 1 prime. Okay, and the bottom one, because it came from 2 likewise, we're going to call that one 2 with a dash or prime. Okay, so what are we going to do then? We're going to work with these 2 equations. First of all, for example, if we want to find, let's say, if we want to find a, we will add the 2 equations to get rid of the b. So we go 1 prime plus 2 prime, and we get, so we add these 2, that's, so of course on the left hand side if we add we just get 0, 0 plus 0, 0. 49a plus 49a, we get 98a, minus 7 plus 7b, they cancel, so minus 7 plus 7 we get 0, 2 plus 2 we get plus 4, and therefore we get, so rearranging this, we get a is equal to, take minus 4 to the other side, minus 4, and divide both sides by 98, we get minus 4 over 98. Okay, so that is our a, and if we want to simplify that slightly further, we can go minus 2 over 49. All right, so we got our a, so I'll highlight this. So here we have our a value. Now, the way, again, simultaneous equations work, once we find one unknown, we're going to start substituting back. So we're going to put this a back into either of these 2 equations. Okay, they will both give the same answer. So sub 1, so if you sub a into 1 prime, what we get is we get 49 times minus 2 over 49, I'm running out of space, minus 7b plus 2 equals to 0. Okay, so then from here, if we go 49 over 49, so this cancels, we get minus 2 plus 2, that also cancels. All right, and then we get minus 7b is equal to 0, which means b is equal to 0. All right, and so this is also, we can also highlight this. Same highlight, a different color due to the background. Okay, And like I said, we can even put it into equation 2 if we like. So even if I just want to prove that to you, I'll go sub also a into 2. Well, I probably shouldn't be proving this now given the amount of space I have, but anyway, into 2, right, what we have is 49 times a again, so that's the same, minus 2 over 49. And then this time instead of minus 7, we have plus 7b. Again, plus 2 equals 0. Again, 49 at the top and 49 at the bottom. When you multiply, these will cancel. 49 49ths is 1. And then we're left with minus 2 and plus 2. This will likewise cancel each other. And again, we have 7b is equal to 0, which means gives us b equals to 0 as we divide or multiply, as we divide both sides by 7. Okay. So now we have a, we have b, and the last thing we want to find is, well, what is it? We already know it, don't we? So we already know our c, which is this one over here. All right, so our 3 unknowns, we have found them. And now when we substitute it back into our very original equation, being this one up here, now getting pretty colorful. Here's our original equation. Getting very colorful with the highlighters. That's our original equation. Substituting it back in there, we get y is equal to, we know a is minus 2 over 49. Minus 2 over 49 x squared plus b. What is our b? Our b is 0. And then 0 times x, it's going to be 0. Plus c is 2. So to write this slightly simpler, we can say y is equal to minus 2 over 49 x squared plus 2. So this is the equation that we have. This is the answer. Okay, so I'm gonna take that answer. So I'm going to take this answer down on the bottom right hand side where we have a bit of space, just so we remember it and we can try it out afterwards. Let's say green. I think green should work well. So for standard form, it works well. For standard form, we have our answer of the model of this Sydney Harbour Bridge is minus 2 over 49 x squared plus 2. All right, so as I said, this first standard model in this case is probably the most complicated way of doing this out of all three. But as I said, I did it just because it was the first one there. Now that we've got the complicated bit out of the way and that I've scared half of you already to get off to stop the video and move on to doing something else. Now what we can do is go on to the second one. So here we have vertex form.